Sorry, can you hear me? Yes, I'm here.
Yes.
Okay. Yes, we can hear you. Okay. Then Jianxin will chair the keynote-based session for Jenny. So over to you, Jianxin.
Yes, thank you, Xiao, and thank you, Jenny, to join in this session and give us the keynote speech. I think I know Jenny a long time ago, and while previously while I worked at RMIT, I know Jenny has done a lot of excellent research, especially in the fake news detection, and now Jenny is a full professor of data science at the School of Computing Technology, RMIT University, and her research appearance in data mining, machine learning, text mining, and social media data analytics. And she has published, I think, over 100 high-quality research papers in these areas, and has got a lot of research funding. And thank you, Jenny. And I leave the time to you.
Thanks, Jianxin. Thanks, Jianxin and Xiao for inviting me to talk about my research and this wonderful opportunity to meet with other researchers who are working in this area. So I'm here to share what we have done in the past couple of years. As the title suggested, we work on misinformation on social media research, and from detection to mitigation. Okay. So nowadays,
do you have your slide to share?
Oh, sorry. When I share, I thought I shared my screen. I'm sorry. I thought I shared my screen. Where's the share button?
Oh,
Yeah.
good. Yeah, fantastic.
Yeah, that's better. All right. Okay. Sorry. I just okay. So I don't usually use Zoom. We use Teams at RMIT. So here. So in the age of the social web, and more people seek information from social media platforms. So here you see a few. I listed a few. So Twitter, Facebook, and YouTube. And the one at the bottom is the Chinese Weibo, and it's the equivalent of Twitter in China. So people share all sorts of information and even news, actually, and on the social media platforms. But social media platforms are double-edged sword. So on one hand, people share news and useful information, but on the other hand, there is all sorts of misinformation or false information on the platform. Okay, and you can see here, I give a few examples. This one on the top left is the fake news crisis by Facebook. Because for the 2016 U.S. Presidential election, so it was claimed that Russia influenced America's election through spreading propaganda and disinformation on Facebook, and the one in the middle is during the 2019 coronavirus pandemic, and all sorts of misinformation from home therapy to origin of the virus to conspiracy theory, all sorts of misinformation spread on the social media platforms. And this one, it actually, because of the home therapy, the therapy says drinking alcohol actually methanol is type of alcohol, and if you drink that, it can cure the coronavirus, and it caused deaths in Iran. So that was about it. Okay, and this the very last example is a page from RMIT ABC fact check. Actually, there's a warning on the page because of our forthcoming federal election in Australia in May. So warn people, the election is coming. Are you ready for the misinformation? Okay, so you can see here the misinformation is causing all sorts of problems, and the topics ranges from politics to health and to election, politics, and all sorts of different topics, even a natural disaster and even science. There are pseudoscience information spread on the on social media platforms, and there are it spreads and it takes different forms. Sometimes it's like the political misinformation. They are actually disinformation. They are propagandas by some states with some purpose, trying to purposely deceive people. Okay, it can also be rumors, and you know, when the truth is not known, people start spread rumors about the current events. And it can also be hoax, like in here. This, I don't know, anyone knows this, looks familiar, this very scary image of a person. This is a character, actually. It is called Momo. And it actually got viral in 2018. And it set up a challenge and enticed children to do all sorts of dangerous, to perform all sorts of dangerous tasks and, you know, hoax. And there are also clickbaits. You know, there's a headline and entice people to click and look into the content, but the content is actually irrelevant to the headline. Okay, and there are also trolling and hate speech, and so all takes different forms. There are various different forms of misinformation on the social media platform, and so because of this, you can see here. Look at the example. If you look at this this picture here, it may look real. It's talking about some natural disaster, about the New York Police Department, and well, if you believe it, actually, you would think, oh, something terrible has happened. You got, you know, people would get into panic. But actually, this is a false picture, and this is misinformation. And this one is talking about Bill Gates invented the vaccine to get people's personal information. And this, you know, during Donald Trump is a big user of Twitter, and his account actually was shut down by Twitter because he tweeted all sorts of you know, claims that are unverified and not true. Okay, so all these different forms of misinformation and attracts the interest of researchers, both from journalism and media studies, as well as computing technologies. Okay, and some research has been done to study how misinformation spread and why does it spread so wildly. And these two science papers actually are published. They are two science papers in 2018. And this one, the spread of true and false news online, and used 11 years of Twitter data to study the spread of true and false information on the Twitter platform. And they found that false information spread farther, deeper, and quicker than true information. And in contrast, compared with the true information, okay? And the science of fake news in the same issue of the Science Journal is talking about the political fake news, and from the social science perspective. And why can misinformation or and fake news spread so quickly on the social media platforms? Actually, there are studies also study what plays the major role to spread the fake news. Actually, it was found in this science paper, the spread of true and false news online. In this paper, it was found that it is not actually machines and that are spreading these the misinformation. It is actually humans who spread the fake news and the false information. And you can see here humans play important factor in spreading the false information online as well. And this actually is confirmed by this study here, as the title suggests. Students have dismaying inability to tell fake news from real. So this is a Stanford study in 2016. They found that people are credulous. They just believe in the information that they see. And so that's the reason why they don't want to spread the false information intentionally, but they may spread the false information unintentionally, or because they find the information is novel. That was found similarly in the science study. And actually, we did something similar. This was done a piece of work that we did in 2017. This was a paper that we did on people's perception of the credibility of information on Twitter. And what we found is actually people's trust the information, on the surface level, the information presented on Twitter, more than the machine prediction. You know, when we use machine learning models to predict the credibility of information, the machine predicted, but users would tend to believe that. So we studied the demographic features of users who would believe in the information presented in tweets, as well as are there differences across different topics, and the content, the language and linguistic features of the tweets, how would that interact with human perception of the credibility of the information presented in tweets. So that's some background knowledge. So to combat misinformation, as I mentioned just now, and there are social science researchers, mainly from journalism and media studies. They do fact-checking. So there are fact-checking services by media professionals around the world. RMIT ABC Fact Check and RMIT Fact Lab actually follow closely especially the political event-related news. They check the claims and publish their verdict as, is it in green, red, or is in the red zone or the green zone, or it is in the neutral. Okay, and here I have listed a few other fact-checking services around the world. And that's from the media professionals. And for computing researchers, so to achieve detection at scale, actually, manual fact-checking is costly and time-consuming. So automated detection using AI and machine learning models, mainly by computer science researchers, and the tech companies like Facebook, like Twitter, they all keenly apply automated methods to detect misinformation at scale. Okay, so that's the background information. And so in this talk, I will next discuss a few studies we did for the early detection of misinformation and to the mitigation of the misinformation. So from the background, you can see that despite the effort of detection, the misinformation still spread and wildly. And, especially as we can see that there's a term, I think, from the opening talk just now. So the term infodemic, it's like a pandemic that has been spread across the world. So I think to combat misinformation is not only detection is the finish of the story. It should, how do we mitigate, that is to combat the spread of misinformation. So these are the three pieces of work we have done towards the detection and towards the mitigation. So the first piece of work we have done and is rumor detection via zero-shot cross-lingual transfer learning. So we use machine learning methods trying to detect rumors from one language and transfer the model to another language. Okay, so here is the motivation. So as you can see here on the screen, the annotated for machine learning models, to train a machine learning model, we need labeled data with annotations. So annotated rumor resources are mostly in English. As you can see, there are several data sets that are publicly available. So rumor eval is a semi-eval data set, and Twitter 15, Twitter 16, and as well as FIMI. They are widely used rumor detection resources and with annotated labels, true rumor, rumor or not rumor, or whether it is true rumor, false rumor, or unverified rumor, with all these labels. So the labels with the annotated resources are important to train the machine learning model to do the rumor detection. And there is also Weibo in Chinese. But majority of the resources, annotated resources, are in English. But Twitter posts are in 40 plus languages. And for significant events like the pandemic, the most harmful rumors spread quickly across the globe and in different languages. So the low annotated resources for non-English languages, it is a challenge to train a model for rumor detection because there are no annotated data to train an accurate model. So that's our motivation. So our research question is therefore how to achieve cross-lingual rumor detection not requiring annotated data for the target language. So that's what we are trying to address. So as is illustrated in this diagram here, what we have is data with annotations, with annotated labels in the source language, most likely English. Okay, so from here, how do we train a model, a rumor detection model through supervised learning? So to train that model, and then we can transfer this knowledge so that to apply to a target language, but without any annotated resources for the target language. So that's the research question. So our solution for the research question is we for the rumor detection, what we did is we actually use this idea of crowd intelligence. So the main idea is to classify a source post, say like a source story, to classify and predict whether it is a rumor. We not only use the textual content of the source post itself, but we believe the crowd comments, the stance of the crowd comments towards the original source post. It often says this cannot be true. It has some stance either to agree or disagree, to support or against the source post. And if most people say the original source post contains false information, it is not true, and then we can make the prediction. So that's the idea of leveraging the crowd intelligence. And the underlying classification model is based on the pre-trained multilingual language model, so such as multilingual BERT. There are many large-scale pre-trained language models from NLP research. So we make use of that, make use of the pre-trained language model, use the language embedding, and then supervise with the label, and then we train a rumor detection model. Okay, so that's the how do we do the rumor detection. Now, the supervision comes in label data in English. but how to once we train the model, how to transfer it to a different language. So we do it in a zero-shot fashion. So zero-shot means we use zero annotated data in the target in the target language. So to achieve that, and this is what we do. So we actually used what we call a self-training loop. So what we do is say this is the original BERT. The BERT is the pre-trained multilingual language model, and it is trained based on the supervised data, for example, in English, in one language. And then we just apply this model to the target language. And because of the classification, it will generate prediction labels. But these labels, they are not gold labels, they are silver labels, because they may be true, may be false, and but depending on the confidence. So we apply a process to distill the reliable predictions here and use them together with some strategy so that we can use it to further train a student model in the target language. And with this, and after the student model can be applied back to the source language, and this co-training process can improve the finally trained the student model and the teacher model. They both got improved in classification accuracy. So the key thing here is to do this self-training. It's like use the trained multilingual language model to predict, make the prediction applied in the target language. Okay, so here is some details. And you can see here we made use of the pre-trained language model, and it is actually multilingual BERT or multilingual Roberta. And then here is the sequence that we use, and with the cross-entropy loss for rumor classification. Okay, so here is the self-training loop. So the self-training loop is from the teacher model, we apply it to the target language, and then there is a feedback loop, and the student model is trained to feed back into the teacher model. With this loop, we improve both models in the source domain and the target domain. Okay, so here are some experimental results where we do the transfer learning, and from English to Chinese, English Twitter to Chinese Weibo data, and from Finny, which is English to Chinese, and from Chinese to English, from Chinese to English, and we have evaluated the performance, and the details are reported in the paper. If you're interested in find out how do we do the self-training and to prevent false transfer, to in the process. Okay, so that's how we do the multilingual detection. And the next piece of work we have done is to do the mitigation, and this is what I call the network level mitigation. Okay, so to achieve at the social network level, how to stop the spread of fake news on the social network, what we do is we identify debunkers. They are users on the social network that spread true news to with corrective information against the fake news. Okay, so that's what we call the mitigation on the social network. So the problem we are targeting is how do we identify the debunkers in a cost-effective way with a budget, right? When we are given a budget to select debunkers, how to select cost-effective debunkers, and we achieve to achieve effective mitigation campaigns, we do multi-stage mitigation rather than select K debunkers with the most influential who has the largest number of followers, and we actually do it in an interactive way and in multiple stages. And we formulated the campaign as a reinforcement learning problem, to model the environment of the social network and the information propagation on the social network with this environment. And we train a strategy, train a policy to select debunkers in multiple stages. Okay, and what we found is during the reinforcement learning process, because of the network environment, when we select one debunker, there may be overlapping effect because of the social links. So how do we select it cost effectively so that to minimize the mitigation overlap? Okay, so the main idea for a cost-effective way to select debunkers is more the policy we train. So this is the formulation of the problem. The policy we train is to select debunkers to spread news, true news, corrective news to those users. The users who are exposed to more fake news should receive more intensity of the true news. The more a user is exposed to true news, the more we can change his belief to the misbelief about the fake news. Okay, so that's the main idea. So we have an intelligent agent, and this is the social media platform, which is the environment, and the social network. The interaction between the agent and the environment trains and reinforcement learning through the reinforcement learning process for cost-effective debunking. Okay, and here is some details of the methodology. So the key thing here is we want to model and to train the policy to decide the intensity for a debunker to post true news, the intensity, because post every news is costly. There's a cost associated, so we want to do it in a cost-effective way. And so we compare this approach against the commonly used baseline. For example, max influence is to select the users who has the largest number of followers. So, but large number of followers doesn't mean that they will generate, effectiveness in propagating the true news. And also, so that's why we're doing this interactive reinforcement learning for dynamically selecting the debunkers. And we also compare with max coverage and a few. This is a standard reinforcement learning framework, and this is another framework based on the intensity for reinforcement learning. Okay, so we experiment on both synthetic network and the real world FIMI social network. So I'm just cautious of time and for details. And these are the results on synthetic data, and shows the performance of our approach compared to the baseline approaches. And these is on the results on the real world FIMI social network. Okay, so this is network level mitigation. So the focus of the study is to learn the intensity to post true news against the fake news on the social network. And another piece of work we have done is the network level of spreading. In addition to that, more personalized mitigation. So through personalized news recommendation to achieve fake news mitigation at the individual level. So this is another piece of work we did that just appeared in the web conference. Okay, so what we did is we do a personalized news recommendation in the process to achieve the most effective mitigation. Not only we randomly, in contrast to the previous work, rather than throw lots of true information, we want to focus on true and relevant information that are of interest to the individuals through personalized news recommendation. So that's the key idea that we are using. So the motivation is, as is shown on this slide, recommend personalized corrective information to individuals. So because it is personalized, so it is of interest to the individual, and because of this, it will stop the user from spread misinformation. Okay, so in here you can see here with Timecodes, this is a sequence of news from the reader's reading history, and there are fake news and there are true news. But from here, we want to model the personal interests of individuals so that we can achieve personalized recommendation. But on the other hand, we want to recommend only true corrective information rather than false information in fake news. So several research questions here to achieve our goal. How to recommend relevant news that is of interest to the individual users, and how to only recommend true news without, we have to separately predict the true or false of the news. Do it in one go. And how do we influence to model the events, the latent events that are relevant, which is actually that is the common topic which we can recommend relevant news, because news about the same event would be of interest to the user. Okay, so the problem we formulated as a news recommendation problem, as I said just now. So through the user news interaction data set, and we record the user news interaction and model it so that we can, given a selected new a sequence of news a sequence of news read by the reader, by a user, and we can model the behavior of the user, the reader interests, and the event, and disentangle the information from the reading history. So what we did is we proposed this overall this neural model. So you can see we encode the news, the embedding layer, we encode the user news interaction. From here, we have a disentanglement layer. So that we can model the event. This is the event detector, and so that we know the user interest, and so that we can also know the veracity, the true or false information about the news. So this neural architecture, through the encoding and decoding process, so that we can get the different aspects of the embedding for event veracity as well as user interest, so that we achieve personalized mitigation. Okay, so here is a comparison with the baselines, because traditional news recommendation and all personalized recommender systems, they only focus on how to satisfy users' interest. The existing models don't model the veracity of information explicitly. So this is some experimental results, and on the veracity, of course, because we model it, so we can achieve the most effective veracity. You can see here is a case study, and the reading history and the recommendation are all true news we are recommending, and true news as well as relevant of user interest. Okay, so to sum up, and we did a multilingual rumor detection, misinformation detection through transfer learning. The pre-trained language models, they're very powerful and can be readily leveraged. Okay, and we also did network level multi-stage mitigation through reinforcement learning, and we also do personalized recommendation to achieve individual level of mitigation. Okay, so future work, and there are still challenges. Okay, so our evaluation just now are, using metrics, but they're not lived user experience. That is, can we really change what are users' perception? Can we really change people's perception and stop them from spreading fake news to achieve real mitigation? Okay, so here we have set up an online platform where we have users and we promote news there, and we can do some collect lived user experience, and also we do mitigation. The adversaries, they can use machine learning algorithm to promote false and misinformation. So how to achieve robust mitigation in the presence of adversaries is a challenge. And also an interesting direction to explore is multimodal misinformation detection, and with explanation to make it the detection more convincing and achieve real real mitigation, real effect to change people's perception. Okay, and human is, all I'm saying here is human is a very important factor in the whole misinformation ecosystem. So I want to thank my students who work with me, and also collaborators, and as well as ARC for the financial support. And the works, the studies we presented just now are supported by an ARC Discovery project. And so that's all from me. Thank you. Any questions?
Thank you, Professor Zhang, for your interesting keynote speech. I think I can find a lot of interesting research areas. Yeah, especially your work about the personalized recommendation. I think that's very interesting. Yeah. So is. Yeah, I can say there is a question posted by Dr. Hui Yin, and she asked the first work use the label data for supervised learning and then apply it for cross-language rumor recognition. That is unlabeled data. So how to evaluate the performance of the model?
All right, yeah, okay. Yes, to evaluate the model, we do have the ground truth for the target language. It's just like in the training process, we don't make use of any of the labels. So the situation and the environment we apply this transfer learning to a target language is, where the learning at the learning stage, we assume that we don't have any label data in the target language, and to develop the model. So, but for evaluation, we do have the ground truth only for the evaluation. We use the ground truth for evaluation.
Okay, thank you. Okay, I think that we have another question. Hi, Robert, can you hear me? Yeah, I saw you raised your hand. Do you have any question?
Yes, I can. Can you hear me?
Yes, I can hear.
Okay. Well, thanks, Jenny. I'm Rob Ackland from the ANU. I'm talking later on in the panel session. Thank you for your presentation, Jenny. I just had a question about the second part of your research on mitigation strategies. And you mentioned about how you've tested it with in terms of choosing the most efficient debunkers. One approach is to look at to select users who have very large follower counts, but you made a comment that is not necessarily going to be the most effective way of mitigation. And so I just wanted to ask you what other features, in particular network related features extracted from the Twitter or the social media platform Social Graph, do you think are viable, or have you perhaps been exploring?
Okay, thank you. So for the we did compare it with the, so for the static way of looking at the typology of the network, so not only the number of followers, if you look at one of the baseline approach is, one is max influence, which is the highest number of followers, which is the social network, and max coverage is actually talking about not only the social the followers, but the network typology that is has the largest number of say like the betweenness, the centrality. You know, you can look at the typology. So what we found is these static network features is related but not indicative of the information propagation. So for specific topics, you know, like there is a famous paper from ICWSM, I can't remember which year. The title of the paper is "The Million Follower Fallacy." That is, this social network, this network architecture, although it seems that you have lots of followers, but for different topics, the information propagation is different from the social network, put it that way. So that's why there are all these looking at the dynamic information propagation process to design appropriately to train the model to select the parameters more interactively and more dynamically rather than using the static network structure.
Okay, thank you. Thanks.
Yeah, okay, thank you, Jenny. I think considering the time limit, we don't have time to answer the question. And I think if our attendees or participants, if they have a question, I think they can directly email you and contact with Professor Jenny Zhang in the future. Thank you, Jenny, again for your support, for your very kind, great keynote speech. Thank you.
Thanks, Jianxin. Thanks, everyone. Thanks for giving me the opportunity. Very glad to share my research with all of you. Thank you.
Thank you.
Thank you.
So let's move on to the next keynote speech. Hilya, are you there?
Yeah.
Yeah, I think you can share the second keynote speech.
Okay. Thank you, Jianxin, for the opportunity to me. So we will continue with the second keynote speaker today. We have Dr. Usman Kasong. He is a Director General of Public Communication and Information in the Ministry of Communication and Information Technology in Indonesia. Prior his role, he was the Chairman of Editorial Board and News Director in Media Group. He obtained his PhD in Communication Studies in University of Indonesia. Okay, without further ado, please welcome Dr. Usman Kasong. Over to you, Dr. Usman Kasong.
Okay, thank you, moderator. I have sent my presentation to the committee and fake news detection and intervention. Next slide, please. Yeah, according to Edelman Trust Barometer 2022, the worry of the people on false information or fake news being used as a weapon, according to the survey, increasing at least 4 points globally, 76%, including Indonesia. Indonesia, about 83% people of Indonesia worry about false information or fake news being used as a weapon. Next slide, please. Hoax findings in Indonesia from August 2018 till March 2022, total 9,746 hoax. But the good news is there is declining. Yeah, there is a declining of hoax findings in Indonesia from 2018 to 2022. You can see in the graphic. Next slide, please. Hoax issues categories, August 2018 until March 2022. Health. Yeah. Health is the hoax issues categories 2088. Government, politics, scam, international crimes, slander, disaster, religion, myths, education, tradings, and others. You can see the amount or the data here in my presentation. For example, government, 1,856 hoax. Next slide, please. From 2018 to 2021, Minister of Communication and Informatics has managed more than 1 million negative contents from Twitter only. Facebook and Instagram and also WhatsApp contributes to around 40,944 negative contents. Next slide, please. Low digital index. Yeah, we believe that negative content, fake news, or hoax is because of the low digital civility index. For example, Microsoft Digital Civility Index 2022 found that digital civility in Indonesia is the worst among ASEAN countries, 76 points. Hoax and scams, 55%, hate speech, 31%, and discrimination, 15%. Next slide, please. Hoax categories, there are 5 hoax categories based on low number on electronic information and transaction. Low number 11 of 2008. First, defaming or slandering. Second, harming consumers. Third, discrimination. Fourth, causing trouble. And fifth, potentially causing trouble. Next slide, please. We have a regulation of Minister of Communication and Informatics of the Republic of Indonesia, number 5 of 2020. The private scope electronic system operators have to fulfill first, overview of the operation of electronic systems. Second, the obligation to ensure information security in accordance with the provisions of the laws and regulations. Third, the obligation to protect personal data in accordance with the provisions of the laws and regulations. And the fourth, the obligation to test the reliability of electronic systems in accordance with the provisions of the laws and regulations. Next slide, please. There are 3 layers strategy for us to handle the fake news, the hoax, misinformation, disinformation. The 3-layer strategy are upstream, downstream, and also midstream. In the upstream strategy, we have digital literacy program. This is such a mitigation strategy. In a digital literacy program, we educate people to spread valid and positive information in order to stop hoax and negative contents. This program is targeting 50 million people to participate until 2024. Next slide, please. Digital literacy by Ministry of Communication and Informatics. We have three education materials. First, digital skills. Individual skill in knowing, understanding, and utilizing IT software, hardware, digital operating systems. The second, digital safety. We educate people to have ability in identifying, analyzing, and enforcing awareness of digital safety. The third, digital culture. We educate people, we educate individuals to have ability in elaborating and enforcing the values of Indonesia ideology, Pancasila, and diversity in unity. And the fourth, digital ethics. We educate people of Indonesia to have ability in implementing and considering digital ethics, or we call it netiquette. Next slide, please. In the midstream strategy, we take down the negative content. We ban the negative content from digital platforms. MCI, Ministry of Communication and Informatics, take down negative contents from websites, social media, digital platform, or specific accounts spreading negative contents. We have a cooperation with digital platform such as Facebook, Google, and so on. We have crawling machine. We call the machine ICE to detect hoax in daily basis. MCI also provide channel for people to report negative contents they find in digital platforms. Next slide, please. This is the email address for people to report the negative contents in the social media or digital platform. Twitter @aduancontent and email aduancontent@mail.cominfo.go.id. Next slide, please. And in the downstream, this is the government's role in securing cyberspace. Law enforcement, together with Indonesian National Police, we take cybercrime to legal actions, starts from investigation to administering criminal sanction. Next slide, please. Thank you. That's all my presentation.
Thank you, Dr. Usman Kasong, for the insightful information and presentation today. We still have time, so does anyone have a question? Maybe you can raise hand, or also you can put your question in the chat box. Okay, maybe I will ask a question, Pak Usman Kasong. I am really interested about the strategy that you already presented in the slide, downstream, upstream, and also midstream. So actually, what the education that in the upstream strategy that already conducted by the MCI?
Yeah, like I said before, that we have the program. We call it digital literacy. Digital literacy. This is the basic education, yeah, for the people in digital skill. We have middle level. We have digital literacy in the middle level. We call it the digital scholarship academy. And in the higher level, in the advanced level, we have a program digital leadership, digital leadership academy. In the middle level, we have the program digital scholarship. Yeah, digital scholarship. So we have complete enough for people to educate people so they have digital literacy. This is, I think, the mitigation. Yeah, the mitigation for us to dismiss or to decrease the misinformation, disinformation, and also hoax. Yeah.
Okay, so who are the target for the digital scholarship and also digital leadership that you mentioned before?
Literacy digital, the target is general people. Yeah, in Indonesia, we have the target, like I said before, 50 million people to be educated via digital literacy program. And for digital scholarship, we also targeted general people. But for digital leadership academy, we have a target for government employee.
Okay. Okay, thanks, Dr. Usman Kasong. Anyway, do you have any question for Dr. Usman Kasong?
Yep.
Maybe
Hilya, can you hear me?
Yeah, I can hear you.
I'll be very small in the screen outside where I'm taking.
Sure.
Yeah. So thanks, Dr. Usman Kasong, for your presentation. This is Xiao. I'm leading this project with Hilya at UGM. You know, our project, as the title shows, is a multilingual COVID-19 fake news detection and intervention. I think one of the motivation for us is because, like Australia and Indonesia, we are all this kind of multi-language and multi-culture country. And I do think, like, you know, with all this, I think we have like over 100 ASCO groups, like speaking different languages. And do you see that as a kind of a challenge for your government to manage this kind of managers of the detection or like a control of the fake content, because this could be like in all sorts of different languages and spreading among different ASCO groups. So do you think that is a challenge, and if it is, do the government have some kind different kind of program to support, like, education and or this kind of management across the different ASCO groups?
Yeah, I think it is very possible for us to cooperate. Yeah, we have Directorate General of Informatics Application. Yeah, so I think you can cooperate with my college in MCI, the Directorate General of Informatics Application. Yeah, they are preparing the application, yeah, to detect, for example, hoax in different language also, I think. Yeah. So it is very possible for us to cooperate together.
Yeah, that's great. Thank you.
Thank you, Xiao. We have one more question, Dr. Usman. how do you explain the decline of the fake news in Indonesia lately on recent years, especially during the pandemic of COVID-19?
Yeah, I believe that it is because we educate people. Yeah, we did the education for the people, like I said before, via literacy, digital literacy programs. And you know that via this literacy program, we educate people to fulfill, for example, to fulfill the digital space with positive contents. And we also, like I said before, we did the taking down of the hoax from digital platforms. The two factors, I think, that cause the declining of hoax in Indonesia, especially in the time of COVID-19 pandemics.
Okay, thank you, Dr. Usman Kasong. Is there any question? Oh, it's still one question, maybe the last question. Over to you, Rian.
Thank you for the time and for Dr. Usman Kasong. I want to ask a question. How long to take down the negative content, especially on websites or social media, and how to inform to the citizens to understand that the content is a hoax immediately?
Yeah, we have MOU with the digital platforms. They must take down the negative contents in 24 hours.
Okay. Maybe it's the last question in this keynote speaker. Thank you, Dr. Usman Kasong, for the insightful and very interesting presentation. And thank you, everyone, for attending the second keynote speech session today. We will have a 20-minute break after that. Have a great day. I will pass it back to Xiao.
Yeah.
Thank you, Dr. Usman.
Okay.
Thank you.
Thanks, Dr. Usman.
Thank you.
Thank you. Thanks, everyone. Yeah, just as Hilya mentioned, we're gonna have a 20 minutes break. So let's get back 3:10. Okay, so we're gonna have a 20 minutes break. Yeah. Thank you very much. See you later.